The James Webb Space Telescope has found evidence of human activity far from Earth, bringing us closer to answering the age-old question of our solitude in the universe. The research for extraterrestrial life has been a constant throughout human civilizations, generating thousands of literary works and theories on the subject. Our fascination with our place in the universe and the possibility of not being alone seems to be ingrained in us, driving us to seek companionship even if it's of extraterrestrial origin. We're getting closer and closer to finding answers to questions we really want. But are these answers really what we seek, or is there something deeper at play? In 2021, the Hubble Space Telescope posed a hypothetical question about the future capabilities of our technology. Could our telescope detect artificial light on another planet such as Proxima B? This exoplanet, the closest to Earth, lies in the habitable zone of our nearest star, Proxima Centauri, about 4.25 light-years away. Proxima B was believed to be locked in synchronous rotation similar to the Moon with Earth, with one side always facing its star. The possibility was raised that a technological civilization on Proxima B could transfer heat and electricity from the day side to the night side using photic cells that generated electricity from sunlight. Subsequently, a paper with Manasvi Lingam as one of the researchers showed that significant coverage of the day side with solar panels could be detected by future telescopes. Given that the James Webb Space Telescope represents a more advanced technological advance, now in 2024, there is a possibility that will allow us to expand our search for possible artificial lights or habitable exoplanets such as Proxima B. Thanks to its increased sensitivity and range of capabilities, the JWST may have discovered the light we've been looking for, which could propel humanity towards another great leap in its evolution. But before we dive into the implications of the discovery, it is crucial to understand how this feat was possible. The James Webb Space Telescope mission explores the mysteries of Proxima Centauri B. Throughout history, humankind has sought answers to understand the fundamental questions about the universe, our existence, and destiny. These common but extremely difficult questions have driven humanity's curiosity for as long as we have been conscious. In the current era of exponential technological advances, the question arises as to whether we are any closer to finding answers. While a philosopher might argue that we are still at an early age in our understanding of the universe and ourselves, an astronomer would be excited to share the latest discovery about the cosmos using the technological tools at his or her disposal. Although these advances often go unnoticed by the general public, they truly represent milestones in human evolution. Now, with a world literally at our fingertips, it is time to move forward and explore the universe in ways never before imagined. One of the ways of exploration is through technologies such as the James Webb Space Telescope. This instrument, heir to the legacy of human space exploration, is destined to answer fundamental questions about our place in the cosmos. It has already begun to shed light on the possibility of life beyond our solar system, as evidenced by the recent discovery of possible lights on a planet light-years away. Proxima B, also known as Proxima Centauri B, is a supersized exoplanet orbiting an M-type star. These planets, more massive than Earth but lighter than ice giants like Neptune or Uranus, are a unique class in the universe. Although much remains to be discovered and understood about Proxima B, this breakthrough represents a significant step forward in our quest to better understand our place in the cosmos. The first possible evidence of an exoplanet dates back to 1917. Although at that time it barely captured the attention and recognition of the scientific community. However, it was in 1992 that the first detection of an exoplanet was confirmed, astounding scientists. Since then, many other exoplanets have been confirmed, with another notable example in 2003. By April 1, 2024, a total of 5,653 exoplanets have been confirmed in 4,161 planetary systems, of which 196 have more than one planet. These marvelous discoveries are mostly associated with M-type stars, also known as red dwarfs. Red dwarfs are the smallest stars on the main sequence and are considerably more common in the Milky Way than other stars. However, due to their low luminosity, observing them is not as easy as with other stars. Red dwarfs have different classifications and names according to their temperature and sizes. Often designated as M dwarfs, these stars, with a temperature of about 3,900 Kelvin, have specific characteristics that distinguish them. As for Proxima B, Its mass is estimated to be about 1.7 times that of Earth. Remarkably, it completes an orbit around its star in only 11.2 days, compared to our Earth year of 365.25 days. This gives us an estimate of the size of the star orbiting Proxima B. The star's luminosity is surprisingly low across the electromagnetic spectrum, at only 0.16% of the Sun's luminosity. Moreover, in the visible spectrum, its luminosity appears even dimmer, emitting only about 0.56% of the Sun's luminosity. More than 85% of the energy it emits is in the form of infrared radiation, and it orbits at a distance of about 0.04856 astronomical units from its star. The discovery of Proxima B was announced in 2016, which raises the question of why this particular exoplanet has generated so much interest. One reason is that Proxima B is the closest known star to our Sun, orbiting at a distance of 4.2 light-years, which, while large to us, is relatively short on a cosmic scale. It is part of the triple star system known as Alpha Centauri and, despite its low luminosity, remains an object of great interest to astronomers. The Proxima Centauri system stands out as one of the constellations visible in the night sky, ranked behind only two others known as Sirius and Procyon. However, the most intriguing thing about Proxima Centauri B is its potentially habitable position within the habitable zone of its star. Possibilities that suggest are limitless, which has led astronomers to embark on an expedition to explore the depths of the stellar potential. This is where the James Webb Space Telescope comes in. The four main goals of the JWST include searching for light from the first stars and galaxies that formed after the Big Bang, studying the formation and evolution of galaxies, understanding the formation of stars and planets, and investigating planetary systems and the origins of life. As JWST continues its exploration of exoplanets such as Proxima B, we move ever closer to achieving these goals. The search for extraterrestrial life is a particular area of interest in space exploration. The search for extraterrestrial intelligence, SETI project stems from the curious nature of humanity, exploring all that moves and all that does not move. SETI imagines a kind of cosmic treasure hunt, where instead of gold, we are in search of electromagnetic signals that could be whispers of civilization beyond our wildest imaginations. A surprising discovery made by the James Webb Space Telescope has captured the attention of the scientific world. The detection of urban light signals in space, located at a distance of 7 billion kilometers from Earth, has sparked great interest in the possibility of extraterrestrial life. By focusing on Proxima Centauri B, the closest exoplanet to Earth, the telescope revealed the presence of unusual bright lights emanating from its surface. What could be the cause of these unusual lights on Proxima Centauri B? Could they indicate the existence of life beyond our own planet? For years, mankind has longed and searched for signs of life beyond our own solar system. Any hint suggesting the possibility of this fantasy has been greeted with great enthusiasm. Recently, the scientific community was stunned when the James Webb Space Telescope captured compelling evidence for the existence of life forms in space. While exploring the cosmos and transmitting critical data back to Earth, the telescope observed unique urban lights coming from the exoplanet Proxima Centauri B. These lights, as their name suggests, appear to illuminate a distant city. The idea of the existence of an alien civilization in the star system has perplexed scientists, filling them with wonder. Each is baffled by the possibility that this is the discovery they have all been waiting for. If confirmed, it would mean that there are intelligent life forms that have developed societies beyond our comprehension in our space, and we are just beginning to discover it. Observing these urban lights from a distance of 7 billion kilometers, NASA engineers wonder how long they have been glowing in space, waiting for mankind to develop the technology to detect them. David Kipping, an astronomer at Columbia University, characterizes the exoplanet Proxima Centauri B, where the urban lights have been sighted, as a celestial body with peculiar heating patterns that differ from those observed on other planets. While conventional rocky planets tend to absorb sunlight and emit infrared radiation, this exoplanet exhibits a markedly different infrared nature from its host star Proxima Centauri. This peculiarity has allowed careful observation by the James Webb Space Telescope, JWST, since this instrument is highly sensitive to infrared wavelengths. The JWST, with its exceptional infrared sensitivity, is equipped to probe the clues on Proxima Centauri B because it can pick up even the faintest light signals in the cosmic darkness. It becomes the ideal tool for verifying the existence of possible city lights in the night of Proxima Centauri B. JWST's ability to detect artificial illumination in the cosmos is due to its capacity to operate within an extremely narrow frequency band, 1,000 times narrower than starlight. Proxima Centauri B exhibits an interesting relationship between its stellar features and its surface interactions, with its daytime side adorned with solar panels that harness the energy of its host star, while its night side experiences cold temperatures. The temperature variation on Proxima B, as determined by its atmospheric composition, is an intriguing topic for astronomers. The JWST can effectively probe the planet's thermal emissions to provide crucial data on its atmospheric properties. In addition, JWST's orbit around the Earth aligns with the orbit of Proxima B, allowing full observations of its diurnal and nocturnal cycles in 11.2 Earth days. The next step will be to assess the atmospheric chemistry on Proxima B to determine its potential to support life, focusing on the presence of gases such as oxygen, water vapor, and methane as key indicators of habitability. If elements such as oxygen, water vapor, and methane are detected in the planet's atmosphere, it could mean that it is capable of supporting habitable conditions. However, this process is extremely challenging, as it involves the meticulous capture and analysis of the light rays passing through the planet's atmosphere. Although the James Webb Space Telescope, JWST, has great capabilities for characterizing planetary atmospheres, its focus is primarily on analyzing variations in the concentration of water vapor, carbon dioxide, and methane. Detecting oxygen, a crucial indicator of life, is more limited for the JWST. Despite these limitations, the telescope still looks for other elements such as ozone, which may also provide clues to the planet's habitability. It is important to keep in mind that the JWST cannot explore all potential habitable worlds, as it has limited capabilities and can only observe some of the actual planets closest to Earth. Therefore, astronomers are turning to ground-based observatories such as the Extremely Large Telescope, ELT, which is expected to become operational in 2028 and allow for a deeper investigation of the atmospheric structure of distant exoplanets. Scientists eagerly anticipate the development of future space telescopes that will expand our understanding of exoplanetary exploration. Although the JWST has limitations, it remains a crucial tool for unraveling the mysteries of distant exoplanets. However, future space telescopes will aim to reduce the glare from host stars to better study light reflections from the exoplanets themselves. This presents additional challenges, as scientists must distinguish between gases produced by life and those generated by geological processes on the planet.